Children throughout the world are becoming more sedentary because of technology and lifestyle. This is a major concern because children are having fewer active experiences that develop their brains. In our society, there is a misconception that learning should be more classroom structured and less movement-oriented. Brain research tells us that this is a mistake. Substantial physiological, clinical, and classroom studies demonstrate the strong link between movement and learning. If neurologists agree that active movement is scientifically linked to intellectual development, how early should movement training begin? Babies are born with most of their neurons, billions, but they have few interconnections or synapses between the neurons. As a baby moves and interacts with his world, the impulses flowing through his neurons stimulate the cell fibers to grow more branches and twigs, reaching out to other neurons. When neurons are stimulated through movement, they develop more synapses. The more interconnections, the more capable the child is of learning. Every time a synapse is used, it becomes stronger and easier to send messages in the future. Every time a movement is repeated, less energy is used to repeat it in the future. As an infant repeats movements, the brain groups those movements together in a neural memory. A newborn has very few memories stored in his synapses. As he moves and interacts with his world, his nervous system accumulates more neural memories. A child has neural memories for everything he can do. These sensory motor memories create an internal picture of the body. This body image, stored in the child's nervous system, is called the body percept. The child's brain refers to this internal picture to plan his movements. The more accurate the body percept, the better able a child is to navigate unfamiliar movements. By giving a child many varied sensory experiences like the active movement in gymnastics and swimming, his movement experiences become more plentiful and diverse, resulting in a more developed internal body picture or image. However, without this information, the child would not know where the parts of his body are or how to spontaneously move from one place to another without conscious planning. In their synapses, active children have stored a library of skills they can perform whenever they need them. The process of learning unfamiliar skills is called motor planning. It requires attention from the brain to plan and sequence the messages sent to the muscles. When a child learns a new swim skill, like jumping into the pool and rolling onto his back, he pays attention to every movement and is unable to pay attention to anything else. If something distracts his attention, he will stop performing the skill because his attention cannot be on two different things while he is motor planning and learning. He has to motor plan this new skill many times in order to master it. Because motor planning involves conscious attention, it is closely linked to a child's intellectual brain functions. It is one of the highest and most complex functions in children because the brain must engage the prefrontal cortex and the rear two-thirds of the frontal lobes to learn a complex new skill. This is an area of the brain often used for problem solving, planning, and reasoning. Motor planning depends upon very complex sensory integration throughout the brainstem and cerebral hemispheres. It is the bridge between the sensory motor and intellectual aspects of brain function. Physical educators and coaches are teaching a great deal more than swimming and gymnastics. They are building new neural pathways, preparing a child's complex cognitive reasoning for academic achievement. Movement helps to develop the whole nervous system. The child needs to progress from the brainstem up. That's nature's way. Educators and caretakers need to supply the very young child with movement opportunities so they'll be ready for reading, language, and complex cognitive skills in school.